We now have a special message from Smiths Detection, our other platinum sponsor. Smiths Detection is also a longtime World Business partner and supporter of the ACI community. So we're honored to have you here with us today. Please join me in welcoming Mr. Desmond Lian, Head of Aviation Solutions for APAC. Thank you.
Thank you for the introduction. A very good afternoon to everyone. And a greeting to those watching online. My name is Chinwei, or you can call me Desmond. I'm from Smiths Detection. We are delighted to be here today as one of the sponsors for this event, especially after so long. A big thank you to ACI APAC for organizing this in such fluid times, providing us with a much missed opportunity to network face-to-face just like pre-COVID times. My topic today is moving towards open architecture, or in short, OA in the context of aviation security. OA is a fairly new idea within the industry and has been gaining a lot of interest in the last 2 to 3 years. Understandably, the industry is now going through a period of consultation, development, or even the consolidation of ideas, perhaps for some not moving fast enough too. In that sense, my aim today is to give you an overview how the industry is moving or working together step by step to realize the OA vision. But before I do that, please allow me to use an example to visualize the OA concept. OA is a very familiar thing for us in the personal computer world. We encounter and benefit from it every day, whether we are buying a Wi-Fi router, CD-ROM reader, USB mouse, or application software to do a task. We rarely think about compatibility issue. We expect, and indeed everything works together seamlessly. We never need to worry about drivers, software version. All the required resources are readily available online or offline after the purchase. After a few simple setup steps, all the different components work together in harmony, allowing the user to harness the connected solution to complete difficult tasks. In that sense, OA is so established in the environment, it's easy for us to forget that how much effort was required behind the scene to get to where we are today. Now, turning our sight to a typical airport passenger screening setup, which usually include an X-ray scanner, explosive trace detector, or body scanner, or even the IT infrastructure with a suite of software to manage image routing, data aggregation or processing, and fleet management, etc. It is easy to see that in this setup, compatibility is not a given, okay? Different equipment doesn't talk to each other and works like an integrated solution. Compatibility is not a given in this case. After all, there is no USB port or even a common OS for the different devices to talk to each other. Data exchange and interface between the different brands of equipment often has to be negotiated on a case-to-case basis and often resulting in longer delivery time and additional costs. In fact, it is not just technical, let's say, as the technical challenges, there are also commercial and regulatory challenges that we need to address before OA can reach a point where we can truly call it ready for airport security application. While there are challenges, I'm confident that this issue will be resolved over time as we continue to work on it in a transparent, open dialogue manner and with collaboration. As we speak, various bodies such as ACI and European Organization for Security are already working with regulators, manufacturers, airport, and other stakeholders to identify the building blocks needed to make it possible for data exchange between different systems and develop a unified way to achieve interoperability. For example, EOS has 3 active work streams: technical, certification, and commercial liability. These work streams aim to move the industry one step closer to establishing the standard needed for solutions from different suppliers to work together seamlessly. As a firm supporter of OA, Smiths Detection is very active in all work streams. Using the technical stream as an example, we are working with other manufacturers to define standards and interface needed to enable remote screening or centralized image processing in a mixed fleet X-ray scenario, which we believe is one of the key drivers for OA in the airport. So far, the following has been identified as necessary: DICOS, a standard format for sharing and transmission of image data; ACI developed Airport Community Recommended Information Services for security data definition, and a dictionary of commonly used system-level data. And finally, the REST API for sharing DICOS and other control, signal, and information between systems. As we move forward with X-ray image standard become a reality with DICOS, Airport is certainly going to ask for more and want to leverage artificial intelligence and third-party detection algorithm on these open standard images to increase productivity and security outcome. In anticipation of a system combining multiple algorithms, we are happy to announce today Smith Detection is launching an open source tool called UofL. We know very well measuring the performance of automatic object recognition algorithm using 3D data is time-consuming, and comparing the performance of different algorithms is even harder. To avoid comparing apples to oranges, it is paramount to apply the same performance measurement metrics to all algorithms, whether it is a case of user evaluating a detection algorithm provided by a new vendor or evaluating relative performance of detection algorithm provided by two vendors. Essentially, this tool will give users the ability to compare the detection result of annotated images with detection result of the respective algorithm in a standardized way. We believe this is a key step in facilitating the development and the use of more third-party detection algorithm or AI beyond those provided by X-ray vendor, and is another key objective of OA in the airport. Now, if we zoom out and imagine all the possible use case for OA in the digitally enabled airport, it is clear that the benefits will go far beyond integrating solutions from different vendors and build a best-in-class solution. OA will ultimately spill over to other processes and enable new use cases that was not possible in the past. For example, inter-airport images and data sharing for the purpose of inbound screening. Such setup would reduce costs, improve passenger experience, and lead to fewer proprietary development. With an OA platform, airports could now exchange data and let's say X-ray images and baggage data in advance so that they could be screened at the destination airport way before the passenger arrived, hence reducing transit time, giving destination airport the ability to plan early security action, supporting more effective use of resources and manpower. Above all, this scenario is achieved without the need to invest in additional workstation running different applications because of the different image format. Finally, I would like to underline the importance of taking a responsible approach to OA implementation. All parties need to make sure that the challenges and risks are adequately addressed. Again, using the example of multiple algorithms, let's say we have a setup where 3 detection algorithm or AI developed by 3 different vendors are all running on a single image that is generated in real time to identify different classes of threat. This leads to an inevitable question, which is who ultimately owns the data and responsible for the overall testing. Latency issue is they are run separately on different hardware, final presentation on the look and feel, or even the combined computing resources required to execute this on a large scale. Other related questions on the related topic: who is responsible for fault diagnosis, maintenance, health and safety issue? What happens if one component causes another to malfunction? What will configuration change introduce new vulnerabilities? Will changing one component in the system affect the regulatory compliance status? To create a safe and compliant solution, all potential risks that I mentioned earlier must be carefully considered and mitigated. As we move forward, I have no doubts this issue will be studied, addressed, and both in the technical and commercial perspective, and ultimately be resolved. The future of aviation security will be data-driven, requiring open interface and common data platform formats. Soon, perhaps airports will be able to choose any combination of equipment to meet their business objective. and supplier no longer need to customize solution to achieve compatibility with each other system and transfer those costs to the end user. OA is the means to the end. Smith Detection firmly believe OA is moving in the right direction, a logical progression for the aviation security. We will continue to contribute, invest, and play in a constructive role, working with all stakeholders and using our experience to help realize each step towards the OA vision. And thank you very much for your time. Have a nice day ahead.
Thank you very much. Thank you. We now transition to another